What is up, y'all? It's Mr. Chap, and today we're going to do a graham cracker lab, and it's going to teach us all about plate tectonic theory. Alright, so in today's lab, if you want to follow along at home, you're going to need some supplies. You're going to need some graham crackers. You're going to need some frosting. Here I'm using cherry frosting. It's a very weird flavor for frosting. Alright, you're going to need a cup of water, some fruit roll-ups, some wax paper, and a knife or a spoon or anything that you can spread frosting with. Alright, so for part one, I have some pieces of graham cracker. I wish they would have survived a little bit better. Add some bunch of other pieces, but you know what? Science is messy sometimes. So I have a couple pieces of graham cracker. I have some frosting. This is the cherry frosting. It smells delicious, actually. And I added a little yellow food coloring to make it orange because this is going to represent our magma. I'm going to take our magma, our molten rock, and I'm going to use my knife. I'm going to spread a little bit down here. I'm going to spread out my magma. This is our asthenosphere. It's underneath our Earth's crust, and it's molten rock. It's melted, so it's a liquid. And so I have that there, and I am going to take my graham crackers. Right. So these are going to represent some crust. Right now they're going to represent oceanic crust. So both these are oceanic crust. I'm going to put them right on top of each other, or right next to each other right there. And so what we're demoing now is a divergent boundary. A divergent boundary is when they're moving apart, so they're dividing. So one's going that way, one's going that way. I'm going to do this, and we have the pressure of the ocean, of the water of the ocean pushing down on it. So I'm going to push down and then pull them slightly apart. So I'm going to push down and pull them slightly apart. And what you see here is that we have some magma come up. So we're imitating the divergent oceanic boundaries, and we have magma pushing up, right? All right, for part two, I'm going to use more graham cracker, and I'm going to use fruit roll-up. Okay, so I would not suggest you eat my fruit roll-ups because they are very expired. Anyways, all right, so I have my magma down here. I'm going to, my graham cracker is going to, for this part two, is going to represent continental crust. Continental crust is much less dense than oceanic crust. This is my fruit roll-up. This is my oceanic crust. It is very dense, much denser. Okay, so I'm going to put these together. I'm going to put them right there. Put this one, say right there. And what we're going to do now is we're going to represent a convergent boundary. Convergent means that they're moving together. So this is a convergent boundary between a continental crust and a oceanic crust. So when they move together, I'm going to push them together. When they move together, they're going to, the denser one is going to subduct. It's going to go underneath the less dense one, the continental crust. So the oceanic crust is being subducted under the continental crust, and that's just the way it works, right? So the oceanic crust is denser, so it's getting pulled down. It's going to melt back into magma, and then it's going to come up and it's going to create volcanoes on land. And over here, it's going to create a rift valley, like a basically an underwater canyon. All right, so this is part three. So I'm going to take some graham cracker, I'm going to break it. And so now I have two continental crusts. And what we're going to do now is we're going to demonstrate what happens when we have two continental crusts converging. And so because these are going to be less dense, let's just dip them into a little bit of water here so that we can show what's going to happen. And we're going to, no, I would not eat these either. We're going to put them right next to each other, and we are going to converge. So this is continental crust converging, so they're going to be coming together. And when I push them together, we're actually going to create, it's going to push up, and we're going to create folded mountains. So we have, I don't know if you can see that. Let's see if I can pull this up for you. All right, so you can see right there we have elevation, and these are folded mountains. All right, part 4, we're going to get 2 more pieces of graham cracker, and we're going to talk about transform boundaries. So we're going to put them together right there. And transform boundaries are not when they're pushing together, they're not when they're pulling apart, but they're when they're sliding past each other, okay? So when they're sliding past each other though, they're not smooth. You'll see that these graham crackers are not very smooth, right? And so they're pushing against each other, and they're like trying to slide past each other, and it's building up pressure. Building up pressure, and as it builds up pressure, eventually it's going to slip, and if you can hear it, I don't know if you can, it's very rough. And what's happening when this pressure releases, it's pushing, and it releases, we're having vibrations, we're creating earthquakes. So when we have transform boundaries, we have earthquakes. All right, so that was our lab over plate tectonics. This is a graham cracker lab. So we have different types of plate boundaries. We have ones where they're coming together, right? And when we're coming together, we can create mountains, we can create volcanoes, we can create trenches, right? We have them when they're pulling apart. So when they're pulling apart like that, it exposes the magma in between, and we can create rift valleys, and we can create mid-ocean ridges with seafloor spreading. And then lastly, we can have them sliding past each other like that, and they're building up pressure, slipping, and that gives us earthquakes. All right. Hopefully, this was an informative lab for you. Make sure that you answer the rest of the questions, and have a nice day.